Hi class, so this video is going to discuss with you chemical bonding and electronegativity. So this is going to help you do this handout, and you're going to use this modified periodic table with electronegativity values to complete it. So first thing you need to know is what polarity is. Polarity has to do with sidedness of molecules. And molecules have sidedness when the charges are different. So if there's different charges on opposite sides of molecules, then they're considered polar. If they have the same charges on the opposite sides of the molecule, you would consider that non-polar. The way I remember this is that if this is the Earth, right, and here's the United States in North America, it's a terrible drawing, and this is South America, right? This is the North Pole up here, and that's the South Pole down there. The Earth has sides to it. It has poles, so the Earth is polar. Maybe that's an easy way for you to remember it. Maybe it's not. But there you go. Basically, the idea is that if a molecule has sides to it, it's polar, and if it doesn't have sides to it, there's the same charge distribution on both sides, it's non-polar. So you're probably asking yourself, where did this sidedness come from? Well, it comes from electrons, because the electrons are the only things that can move around when atoms are bonding. So the polarity comes from movements of electrons. And actually, that's where chemical bonds are made. Chemical bonds are made using the electrons, which are on the outside of the atom. Remember how we said the nucleus contains the protons and the neutrons, and then around it are the electrons in the electron cloud. And that's what's involved in bonding. Involved in bonding. So different atoms like to have the electrons to a different extent, and that's what the electronegativity table is all about. These values are kind of arbitrary, they have no units, but potassium, which has a value of 0.9 electronegativity, it doesn't want the electrons that much, where oxygen, which has an electronegativity of 3.5, wants the electrons more. And right off the side of this paper, in the video here, you see that fluorine is the most electronegative atom, which has an electronegativity value of 4.0. It wants the electrons a lot. An easy analogy to think of on this is electronegativity is a tug of war for electrons. That's not the official definition, but it's an easy way to think about it. It's a tug of war for electrons. The official definition is it's the ability of an atom to attract electrons. So if you have two teams that are pulling against each other, right, and one team is much stronger than one on the left, it pulls all the electrons away from the other team. Remember, the tug of war is for electrons. If they pull evenly, that would be a different kind of bond because the rope wouldn't go anywhere. And there's a third kind of bond where one side's pulling a little bit more than the other. And we're going to talk about those kind of bonds that result from those three kinds of pulling. So the first kind, which I'm going to talk about, is an ionic bond. An ionic bond is when one electron pulls all the what's called valence electrons, the ones that are involved in bonding. We'll talk about that more as we go forward. But all the valence electrons to itself. Another way you see this is that one atom donates all of its electrons to the other one. It's just kind of the opposite way of thinking about this. Either one atom pulls all the electrons away, or one atom gives away its electrons. So we end up with a positive charge and a negative charge, like Na plus and Cl minus. Another kind of bond is a non-polar covalent bond. And that's when two atoms with the same electronegativity are pulling equally. Both atoms pull equally on the electrons. So that would be like if you had two atoms of the same type, O and O. They're the same atoms, so they're going to be pulling on the electrons the same amount. So there wouldn't be any charge distribution. It would be non-polar. So you often see for a covalent bond the electrons are being shared. The electrons are being shared. The third kind of bond is a polar covalent bond. And this is when one atom pulls the electrons slightly more than the other. And so this is when you have two atoms that are close to each other on the periodic table, but one pulls a little bit more than the other one. So like carbon and an oxygen. If carbon and oxygen were bonded to each other, the oxygen is slightly more electronegative. So the electrons are going to be pulled a little bit to the right here towards the oxygen. And that would make the oxygen slightly negative. Notice that's it looks like an S, but I kept going. I'll draw it up here for ease. Looks like an S, and I keep going. That's the delta symbol. It means partially. This side is partially negative. This side, which means it's partially positive, because the electrons are being pulled towards the oxygen because the oxygen wants the electrons more. The oxygen side is slightly negative. When the electrons are being pulled away from the carbon becomes slightly positive. So let's see how we can calculate this using the electronegativity table. So let's use the examples I used on the last page. We have carbon and oxygen, right? So we look on our table, we do the calculation. Now the calculation is you just subtract the two values from each other. So you see carbon has a value of 2.5 and oxygen has a value of 3.5. It doesn't matter the way you subtract them because you're just going to take the absolute value of the difference. So you take 2.5 minus 3.5, you take the absolute value and you get 1.0. Remember, absolute value means you take a negative number and make it positive. You look up on that table what 1.0 means. And you see that 1.0 falls in between 0.5 and 1.7, so it's polar covalent. Again, these values are a little bit arbitrary, but they're a good start, a good place to start talking about this issue of pulling of electrons between two different atoms. So this would be a polar covalent bond between the C and the. Now, you have to label which side is positive and which side is negative. So you put a bond in between. And on the O side, the O is the 3.5 value. So we know that that's going to be the negative side. But we know because it's a polar covalent bond, it's not completely negative. It's only partially negative. So we write our delta symbol, delta minus. That means this side is delta plus. So let's do another one. We'll do potassium and we'll do chlorine. So we look on our electronegativity table. So you notice that potassium, the value is 0.9 and chlorine, the value is 3.0. So you subtract those two values from each other and take the absolute value. 0.9 minus 3.0 take the absolute value, and you get 2.1. It's a point right there. Okay, so when you look on that table, you will notice that 2.1 means it's ionic. So you write ionic. And then you, in the box where you have to label the charges, you would write the bond in between, and you would write that chlorine has a total negative charge because chlorine's taking all the electrons away from, all the valence electrons away, the ones that are involved in bonding away from the potassium. So because the chlorine is taking away the electrons, the valence electrons from potassium, the chlorine would be negative and the potassium would be positive. Notice the difference. When it's polar covalent, the charges are partial, using the delta symbol. When it's ionic, the charges are complete. Potassium is a completely positive 1 charge, and chlorine is a negative 1 charge. And then the last example, we'll use the example I used on the last slide, 2 oxygens. We look up the value for oxygen, and oxygen has an electronegativity of 3.5, but there's 2 of them, and when they pull equally on the electrons, you will notice that you do 3.5 minus 3.5, you take the absolute value, and the value is 0. And if they're both pulling equally, you know that the electrons have to be shared. So you see that 0 is non-polar covalent. So you would write O, the bond between the 2 O's, and since there's no charge distribution, you don't label it. So those are 3 examples for you to use to complete your assignment. And so please make the attempt, and I will review your answers with you in class. Thanks.